Now let's just see the next question. Question number 3 says that in the figure the sides QR of the triangle PQR is produced to a point S if the bisector of the angle PQR and the PRS meet at the point T, then prove that the angle QTR is half of the angle QPR. So first of all, it is given to us that this particular angle is nothing but bisecting over here, means this and this angle, they are equal to each other. Furthermore, it is also bisecting. So this portion is equal to this portion, or this angle is equal to this angle. So let's just start with the proof. So first of all, we have to prove that the QTR, let us suppose if I'm just taking it as the angle 1, let us suppose if I'm just taking this as the angle 1, I am just taking this angle as nothing but angle 2. Let us suppose I am just taking this angle as nothing but angle 3. I'm just taking this angle as angle 4, since we know that angle 3 is equal to angle 4, and further I am taking this angle as angle 5. I'm taking this angle as nothing but angle 6. Let us suppose if I'm just taking them as this angle. So first of all, if I'm just starting with the solution of this one, as I am just taking the triangle in triangle PQR. In triangle PQR, we know that the exterior angle in triangle PQR, the angle PRS is the exterior angle. We know that this is nothing but an exterior angle. This is nothing but an exterior angle. So it means that if this is an exterior angle, so PRS should be nothing but is equal to the angle QPR plus angle PQR, because we know that the exterior angle is nothing but is equal to the sum of the interior opposite angle. So using that concept, interior opposite angle, using that concept, we can write it in this particular manner. Let us suppose if I'm just writing it as QPR as nothing but is equal to, let us suppose if I'm writing it as QPR should be nothing but is equal to the angle PRS minus of angle PQR. So I'm just taking out the value of QPR from here. So we have this as PQR. Let us suppose if I'm calling this as nothing but the equation number 1, and in the same manner I am just going to find out the exterior angle for the triangle QTR. So similarly in the triangle QTR, what we can say about the triangle QTR, for the QTR angle, you can see over here that the exterior angle is nothing but TRS. The exterior angle is TRS. So it implies that the angle TRS is nothing but is equal to the angle QTR plus the angle TQR. We can say this again with the help of the same theorem. By theorem, we can say this concept that the exterior angle is equal to the sum of interior opposite angle. Furthermore, we can able to find out the value of QTR from here. QTR. Let us suppose if I am just finding out the value of QTR, so this would be nothing but is equal to angle TRS minus angle TQR. Let us suppose if I am taking as the equation number 2. Now, here we can able to find out the values of TRS and the values of TQR. So what are these? Let us suppose if I'm just talking about the TRS angle. So we know that the TRS angle is actually nothing but angle 6. This is nothing but angle 6. And you can see all by yourself that this particular angle is actually nothing but a half of this whole angle, that is angle 6. We can write angle 6 as nothing but a half of the angle 5 plus angle 6, which is nothing but definitely is equal to the angle PRS. So it implies that the angle 6, which is nothing but the angle TRS, is equal to the half of the angle PRS. So it means that in place of TRS, I can definitely write the half of angle PRS. And in the similar manner, if I'm just moving on here, Then we have the value over here as TQR. So you can see over here that TQR is nothing but the angle 4. Furthermore, we know that angle 4 is nothing but a half of the sum of the two angle, that is angle 3 plus angle 4. So furthermore, angle 4 can be written as the angle TQR, which is nothing but a half of the sum of these two angles, which is nothing but angle PQR. So again using this particular concept, I can able to substitute both of these values over here. So let us suppose if I'm calling it as 3, I'm calling it as 4. So I'm just saying the substitute equation number 3 and 4 into. So if I'm just substituting the values over here, so QTR is coming out to be is equal to half of the angle PQR minus of this is minus of the half of the angle TQR. So this is minus because this is a minus symbol over here. So TRS is nothing but plus of half of the angle PRS. So this is negative, this is positive. Now furthermore, we know that we have angle QTR as nothing but is equal to half of, we have this value as a half of, let us suppose if I'm taking half common out of it, so we are getting the values as angle PRS minus angle PRS minus angle PQR. So from this particular equation, if you'll compare this equation and this equation, so you can see that this equation and this equation, they are actually exactly equal to each other. So let us suppose if I'm calling it as the equation number 5, so we can say that the substitute equation number 1 in 5. So we will get the answer as QTR is equal to half of the angle QPR, and this is exactly what we have to prove over here, that the angle QTR is half of the angle QPR, which is nothing but hence proved statement. This is the thing that we have to prove over here. So this is all about this particular question, and I hope all the steps related to this question is all clear to you. And with this question, this is nothing but the end of this chapter. I hope all the concepts that are related or that we have done in this chapter are clear to you. Now do practice more and more questions all by yourself.